Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY. And today we're going to be conducting a combustion analysis, and also we're going to be testing gas pressures on this York RTU's furnace. Thank you to everyone tuning in to Jumperman Tech. Today we're working on this York rooftop unit. It's actually a chilly day and it is foggy out here in New York City. Thank you all for joining me. First things first, if you find this video interesting or helpful, please drop a like, comment, and subscribe, as I do come out with new videos every week. And let's get straight into it. I'm standing here in the duck right now so you get a nice view of the city. People like to see all that. All right, we're out here in Lower Manhattan. So we're here to do the combustion analysis and also do the maintenance on the furnace side of this rooftop unit. They said the heating wasn't working, so I set the unit to heat on the thermostat. It's 68. It's 71 in the hallways, but it's set to 68 in heat, so that's probably why it wasn't running. So I got my manometer here, and I also have my combustion analyzer. Here's the exhaust. Ooh, I feel heat there. That's how you know it's working. We got fire. So I think they just really didn't realize how to work with the thermostat, honestly. Anyways, if you want it in heat, you have to set it above the space temperature. It's 71 degrees in a 68 with a 68 degree set point, so technically it's not going to start. Let's put this over here real quick. Here's our evaporator fan. And if we open up this little compartment here, that's all we have for heat. So let's just open this up, take that out, right there. Here's our burner section, gas valve, ignition control, inducer fan, capacitor on there, got our air proving switch. Let's see what's going on. First things first, unit is heating, and I got a blue flame coming out of each burner. That's a good sign right there. So here's our thermostat. That right there is reading the space temp. It's already at 72 degrees. Got some fire controls here, control board, capacitors, transformer. I think that's a phase protection module. All right. Let's set the system off. Fan is still running. Eventually this contactor right here is gonna de-energize. They might have a setting here that once the system satisfies, the indoor fan runs for anywhere from like 30 to 90 seconds. So that should shut off, and once it does, I'm gonna pull this disconnect down. Let's set up everything that we want to do and start this baby back up. Oh, the sun is coming out. The sun is coming out. That's a beautiful thing. That is a beautiful thing. Fan turned off, and we're good to go. We don't want nothing starting. Let's go ahead and start prepping here. In our first video, we found a broken wire on this fan motor, and we're good to go. A lot of people were commenting that this fan was running the other way, but it wasn't actually running. Somebody pointed out, actually a few people pointed out, and thank you very much for that, that because this fan was running, it basically just created like a draft and causing this motor that wasn't running to go the other way. Luckily, everything's good now. This is for one circuit, these two fans, and then these two fans for the other circuit, and everything is running. Next video, we found one of two circuits completely empty of refrigerant, and we have a leak in this evaporator coil that's in terrible shape. Man, the only thing is that both circuits are connected to, both circuits are connected to this evaporator coil. I gotta loosen this up as well. I gotta see how I'm gonna change that. Got all these pipes and stuff in the way, so I gotta disconnect this coil. I know I could take the top off and rip the thing off from here, but all the connections are here. So it goes from here and then all in. I wonder how this coil is gonna come. They might need to, I might need to cut it from here and here, and we might need new expansion valves with that coil. I gotta call the manufacturer and see how this thing comes, man. I really hope it comes with the TXVs, right? These are TXVs, thermal expansion valves. I really hope. But these both circuits are going into the same coil. Even though it's 2 circuits in the coil, if there's a leak in the one piece, pretty much you're just done and you gotta replace everything. This is gonna be a big job. Also, just so you guys have reference, let me show you how to even get it up here. It's not gonna be easy. You just need raw manpower. All the LG units that we work on. So we gotta bring it up this step and then another flight down and through there. That, it's not gonna be easy. The entrance is right here. Then we gotta walk all this up and bring it. Gotta take out the other one, bring that one in. This whole building is controlled by LG units. You've seen them in the other videos. There's LG units everywhere in different generations. Anyways, let's get started with this job. This is the gas line coming into the unit. So if we follow that, up top, comes in through here. So this side, let's see if I get a light in there, but anyways, this side is gonna be our inlet and this is gonna be our outlet, right? So inlet pressure, and then down here our manifold pressure. Okay, so on this gas valve we have these little ports that you could take off with an Allen key. Over here is the end. This little circle here, I have a special video how to check gas pressure. And then this little port here, we're gonna close the gas line, pull those out, and attach our manometer. This is a Klein Tools bag, but it's not a Klein Tools manometer. Here is our gas valve. Let's see if we can close this thing. I might need it adjustable. This thing is sitting outside. Oh yeah. All right, well, right now, this right here, you can see is parallel with the pipe. We have to do the opposite on this valve here, and let's close the gas. I got an adjustable wrench. Let's see which way this goes. Right there. Oh, it goes past that amount. Man, they probably might want to change that too. Hopefully that thing ain't leaking. That's just about parallel. Gas should be closed off. All right. And whenever we do this, we're gonna want to do this quick. We're gonna get our wrenches, figure out the right size. Let's see, we're gonna put that in here. Too small. We're gonna get the right size, and we're gonna take off those 2 fittings. Here I have the Fieldpiece SDMN5 dual port manometer. We have to read 2 pressures at once. I love this tool. P1, P2. I'm gonna connect P1 right here, P1 to the inlet, and P2 to the outlet. Let's always make sure you zero out this meter as well. And I got these fittings that are on here, and this all came with the tool. If anyone is interested in any of the tools that I use, I always leave a Amazon link in my video description in case you're wondering. So right now, let's look. You see right there, for the Allen key, I'm gonna take that off and connect my manometer there. And I'm gonna do the same for the one on the bottom. Start with the inlet. Gotta open this up. Hopefully that gas valve is even good, because that thing went past the closing point. I just have it in the middle, so we'll see what that's about. And just a big pain in this tight spot, especially with this. Can't even get this tool in, can I? Now I'm kind of hitting the board, which is basically our ignition control. Anyways, let's take off that fitting little by little, and then we'll hook up my manometer. We're just gonna tighten it in there, and you don't want to over tighten it because you can like break the gas valve. All right, so now I'm just gonna spin this in. You don't need anything special on here. Just tighten it down. Don't make it too tight. It's not that much pressure in here. All right, so that's gonna be our inlet. I'm gonna tighten that down, and we're gonna do the same on the bottom. I'm gonna turn on my meter. hit 0. I'm gonna zero out the meter. Also, I got my little 4-inch crescent wrench. I'm gonna go in there, just snug that fitting. Okay. Honestly, this gas valve looks so rusted. You see I got P1 on the inlet, P2 on the outlet. The gas valve itself looks super rusty. Let's see what that looks like. That looks like some serious rust marks over there. Look at this flame sensor, super rusted. They're gonna need some love over here, but anyways, we got that all together, and this gas valve is ready. Let's get our adjustable on here. Jeez. And open up the gas. Okay. What you got on P1?
P1, I see
8.27.
Yeah.
8.28. So that's gonna be our inlet pressure. Let's look at our unit tag. It says over here, I'm gonna take a picture so you guys can see better, but it says gas supply pressure maximum is 10.5 inches in WC. WC is water column. Then it's also says the type of gas is natural, right? We're using natural gas, stuff you see in the stoves and stuff like that. And then over here, let's see. Oh, okay. Maximum is 10.5, minimum is 4.5. So we got 8.28. So we're definitely in range. And then over here it says our manifold pressure, which is going to be our outlet, the pipe, the side that's going to our burners, is 3.5 inches of water column. Right now we're not going to have a reading right now until the gas valve actually opens, the solenoid in the gas valve. Once you call for heating, it's going to send gas through, and only then will we get a P2 reading. All right, so we have our manometer set up over there, and I also have my combustion analyzer. I should be able to just stick it in through there. I got it like maybe around here at this point, so we should be able to test everything. Let's just flip this. Oh, excuse me. Let's start the unit first by pressing down the on button. This should be a purge. Let's just keep this out for a second. But this thing is going to be purging, and you need to do this in fresh air for 60 seconds. Alright? Just let that be, and then we'll stick it in. We don't want any false readings. Alright, so our meter has finished purging. This is the UEI C161 combustion analyzer. As far as right now, let's stick in our probe. Maybe go like that, and that should hold. Okay, flip our dial. Alright. Something's up, I'm telling you, there's gotta be something up with my oxygen thing. Again, 0%. Anyways, pump is running on the meter. T1, our temperature. Let's start this baby up. Alright, turn the power on. 28. Okay, now it's reading temperature. Mode. Heat. Let's raise it to 75. It is currently 69 degrees in the hallways. It says the sensor's on the 5th floor west side. And look, since 2015, look, it says that they added 2 pounds to circuit 2, so this thing's been leaking for a long time. Whatever. Let's see this thing start. All right, our evaporator fan started. I hear this inducer fan going. Let's look at T1. Our temperature should be rising. No. Okay, it didn't start yet. It's going through its purging, so. Oh, I hear the fire just went on. Now the temperatures are going to be going. And let's look at our gas pressure. Let's give it 5 minutes to average out, but should be at 3.5 inches of water column. It is slightly low at 3.36. Well, let's turn that back on. Slightly low. We want around 3.5 inches of water column. Let's see if we see anything on the inlet now. Now we're at 5.71 when it's passing through. So our inlet pressure is totally fine, and we're gonna want to adjust to 3.5 inches of water column on our manometer for our manifold pressure. Let's see if we see anything. Let's give it a few minutes to average out. It's been about 3 minutes or so. I just wanted you to see, look at the carbon monoxide. Look how it's just rising up. 97, 98, 99 parts per million. This thing is getting high, man. I don't like the looks of that. Let's give it a chance. Sort of see what's going on. Our temperature 331 degrees. EFGC is efficiency gross calculator running 84% efficient. O2 oxygen, we don't see anything. CO2 7.6%. My main thing really is looking at our carbon monoxide, and look, it's already at 128 parts per million. Not a fan of that. Heat loss 15.9%. X air is excess air, but for some reason we're not reading oxygen here. My sensor might be bad. This is only the second time I'm even using this tool, but look how quickly our CO is coming now. Let's give this a chance. Our inlet pressure actually changed to 6.80, but our outlet at 3.33. It's just about where it needs to be, but it needs a little bit of love. What's that? Why is there a 3.5, 3.4 on the bottom? This is the top inches in water column is what we really want. That's our true reading. All right. Let's see what happens. Oh look, 132 parts per million. That's not good. All right, so our CO is coming down at 63. That's pretty good. CO2 at 7.3. Heat loss 15%. Excess air, we're not gonna get a reading. Let's go to Flue 1. Right, CO2 at 7.47. The O2 right at 0. Something's up with my oxygen meter. 84.3% EFGC efficiency, and our T1 is at 334.8, which 335. All seems a bit normal. Our CO at the moment was at 130 and dropping. So I guess on the different stages, I gotta look into it. There might be 2 stages of heat here, so at different stages you're gonna get different CO ratings. 200 parts per million and under is the limit where you're okay. Above that, you got a problem and it needs to be checked. Look, it's like rising. And then it comes down. Let's keep an eye on this, but over here we have a flame sensor and the connection is extremely rusted. I wonder what this flame sensor itself looks like, because that's what, you know, keeps the system running. The igniter, right there is our igniter. We're definitely igniting, we're definitely running, but this unit needs some love. I want to see what that looks like. Let me pull this off. Get a good grip on this connection. That thing is real rusted. Power is off. Even the screw is crazy rusted. Let's drop that here. Let's try to get this off carefully. All right. Tips of this is a bit rusty, and this connector is plain out rusted out. Gonna want to clean those up. Old school trick, take a $1 bill and clean it up. I actually got this little tool. I mean, this is kind of at an angle. Oh man, we're probably not gonna be able to clean this up good. Might just need to do it with $1. Does that something like that doesn't fit, but I wonder if I can clean the connection here. Special little tool to clean flame sensors. Let's see if it works for that connection. Oh, Oh yeah, it actually helped out a bit. Let's run that through. Clean that up. This flame sensor is a lot cleaner. I'll show you some before and after photos. I sanded down over here and over here using this little pad here. You just want to light sand, and also sanded down the connection. Let's put this together and see what's up. I turned the gas valve off, the main manual gas valve, and what I did was I put those little screws back. Look how much cleaner it is here compared to here. All I did was sand that down, sand down all our fittings. Also look at the difference of these burners here versus here. And this whole area, we need some maintenance. So I'm gonna sand all this stuff down, clean it up. Look at how rusted those connections are also over there. Oh boy. Anyways, let's give this a little bit of love here, and we're gonna perform a leak test. Everything looks a lot better. I got this air blaster. I saw a little ad on Instagram. This thing is amazing. Dust in here. Oh man. Whew. That is so much better. I also got this little turbo vacuum from there, so let's set this up. Alright. And vacuum up inside there. Get all this stuff that we couldn't get. But hey man, this thing is pretty awesome too. Let's clean all this debris up. That can't be any good for our furnace. That's awesome. I bought this for like little PM jobs, just to clean up after yourself. You'll be alright. Very light, and it's proven to come in handy. Everything is in much better shape now. Looks nice and clean. This gas valve is creepy though. I don't trust it. I opened up the gas valve, the manual gas valve, and here's my probe. Power's on. There's no lights up here. The higher the light, the higher the leak. What I'm gonna do is check my connection over here and kind of just inspect around. The other gas valve part is gonna open only when you call for heat. Let's just do a quick inspection here. Make sure we got no leaks. All right, that gas valve is super rusted, man. Everything looks good there. I even checked other connections on this gas line. What I'm gonna do is just spray this edge and spray this edge, because you can't really check this unless, you know, the gas valve opens for our outlet, so you won't really see that. And also you'll probably get a whiff of gas when this starts, because it's going to let out gas to everything from here, so you can get some false readings. So I'm going to spray it. Today I'm using the Big Blue Sub-Zero. And what's awesome is that this is good in freezing conditions. So we got our leak check solution there. We're going to keep an eye out for the bubbles where we took off the connections. We want to make sure that's good. And yeah, start this up. Got the system running right now. Gas valve is open. Light in there, looking at it, got no leaks, everything looks good. That's a big difference. That's going to keep them running. They definitely start. There's a lot of rust spots in here. That ain't good, but they definitely running, so that's good. They're gonna be all right. That's what's gonna keep them on. And I'm doing a final combustion test. Hopefully you guys can see those readings. Let's go to Flue 2. Alright, 122 parts per million with the CO, 23. Let's keep that closed. See if anything changes. Alright, look at that. Coming down. Let's keep that closed and get our final readings. Keeping this a little bit away so it doesn't melt my probe or hit any of the wires, but still at 111, 112 parts per million. During my last visit, we found the belt was loose, the evaporator fan belt. We replaced that, And we also found these filters packed with dirt, and they got brand new filters as well. We did the preventive maintenance for the furnace, wasn't fully showed in this video, but we also conducted the combustion analysis. We also checked gas pressures, we cleaned everything, checked our connections, and just monitoring the system. We should be good to go. Between different stages, our CO levels will drop or rise depending on which stage of heat there is. Oh man, look at that. Our levels are coming down, CO levels, and look, temperature is coming down. That's because our heat shut down, man. Let me check something. Did we reach temperature? I doubt it. It's showing 72 in the space, right? And I have it set to 80, so you see that? All those rusted connections and stuff like that. Probably the flame sensor is bad and it's cutting you off short. Everything starts, so our igniter is good and everything. The ignition control, stuff like that is good. But for the fact that our flame sensor was rusted out like we saw, even though we try to clean it, that thing most likely needs to be replaced. That thing is out. So yeah, we got heat, but it does shut down. That's gonna be a separate video, but this is why you gotta do maintenance, guys. Let's look at this real quick. 1, 2, 3, 4 flashes. Here's our old coils and 4 flashes. Limit switch open. Interesting. Yeah, they're gonna need some love over here. They're gonna need some they're gonna need something, man. Unreal. It's time for some upgrades here, but we're gonna wrap it up from here. If you want to know how to adjust gas pressure and stuff like that, I have a video separate from this where we do it on a boiler, but it will be the same thing for a furnace. I'll show you exactly how to adjust gas pressure and how to test gas pressure. I'm gonna leave a link for that in the video description. And I'm gonna have a video also separate for combustion analysis where I go into detail with everything that you're looking for and stuff like that. So that's gonna be also in this description. But we're looking okay here, but this unit definitely needs some love. I'm gonna wrap it up. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week, and I will catch you all next time.